We will now try problem 6 from projectile motion A. And in this problem it says, Steve fires a shell horizontally from a tank that is located 144 meters above a horizontal plane. The shell has a muzzle speed of 80 meters per second. So the first thing you want to do is draw a picture. To show what's going on. Now, the shell will come out, come down, and hit the ground 144 meters below where it's fired. So what I do is I break this up into the vertical and horizontal cases. And in the vertical, remember we have VI, Y, VF, Y. We have A, T, and D. And this is AY and DY. So the variables we have for this one, we don't have T. As a matter of fact, in part A, we're looking for T. So for part A, we want what is the time. So our initial variables are going to be our VI in the Y direction, since it's being fired horizontally. VIY is 0 meters per second. Our VF we don't know. Our acceleration is negative 9.8 meters per second squared. Our T is what we're trying to find. And DY, since it's going downwards, is negative 144 meters. Now for the horizontal case, all we need to do is write down that our Vx, which is what his firing speed is, which is 80 meters per second. Because once again, when he initially fires, it's being fired in the horizontal direction. So to find how long it's in the air, we only have to look at the vertical direction. So looking at our equation, we're looking for T. We have VFY missing. So the equation is going to be V sub y is going to be equal to VI y t plus 1/2 AY t squared. Now, in all the cases with projectile motion A, we're firing horizontally. So the VIY is always 0 in all these problems. So in order to solve this, we have to recognize, first of all, since VIY is 0, that whole term will go to 0. So we get negative 144 meters is equal to 1/2 times negative 9.8 meters per second squared times t squared. So negative 144 meters equals negative 4.9 meters per second squared times t squared. Divide both sides by negative 4.9 meters per second squared. Divide this by negative 4.9 meters per second squared. And you get that t squared is equal to 144 meters negative over negative 4.9 meters per second squared. The negative signs cancel. Take the square root of both sides. And you'll find that the time that it's in the air is going to be 5.42 seconds. The next question is how far horizontally, what was the horizontal distance traveled by the shell? So in part B, now that you have the time, the only equation you have in the horizontal direction is that dx is equal to vxt, which in this case, we know that Vx is 80 meters per second. times the time that the shell was in the air, which is controlled by gravity. And this is equal to, multiplying the 80 times the 5.42, we'll get 434 meters. And finally, it says, what is the velocity of the shell just before it hits the ground? In this case, you already know that in part C, you know that the x velocity does not change. So when it hits the ground, the x velocity is 80.0 meters per second. So what you need to find in this case now is the final velocity in the y direction. So using VFY equals VIY plus AY times t, we will get that VFY equals VIY was 0 plus negative 9.8 meters per second squared times the time, which we found in part A above, 5.42 seconds. And that, in fact, equals negative 53.116 meters per second. Now what we have to do is combine these. And to combine these, we use the Pythagorean's theorem and the inverse tangent, so that we get the overall velocity, v equals the square root of 80 squared plus negative 53.116 squared, which is equal to 96 meters per second. Now we also have to find the angle of this. And if you look to see, this is you have 80 this way, negative 53. This will be in the fourth quadrant, is what we're looking at. So the angle for the resultant will be equal to the negative of inverse tangent of the y value, which is 53.1 over 80, or you get that the angle is equal to negative 33.6 degrees. So the overall velocity, final velocity, is 96 meters per second at an angle of negative 33.6 degrees. Solving the problem.